This is 2014 calculate part number 2. Given the polar coordinates and the polar graph R1 and R2. R1 is a circle, R2 is this shape. Part A, how do you find the shaded region area? If you look at the area here, it has two parts. One is here following R2, and the second part is following R1. So area will be the sum of the circle, quarter of a circle, so it's 9 pi over 4 plus 1/2 integration. When theta equals 0, R2 start from here. When theta equals pi over 2, R2 will get here, so it's from 0 to pi over 2. R2 squared d theta, which is 9 pi over 4 plus 1/2. We just need to plug R2 in. Use your calculator. The answer is 9.780. So if you look at the rubrics, 1 point for the limit, 1 point for the integrand, 1 point and 1 point here. Part B, find for the curve R2, find the dx over d theta. As we know, x equals r cosine theta. So we plug it in. Now we can plot this into the graphing calculator. When we plot this into the graphing calculator, we treat x. We can plot y equals 3 minus 2 sine 2x times cosine of x. And directly find the graph it, and second trace to find dy over dx. So with the answer, when we plug theta equals pi over 6, the answer is negative 2.366. So this is how we plot this into the graphing calculator. So 1 point for the expression and 1 point for the answer. Part C, the distance between two curves changes from 0 to pi. So if you look at from 0 to pi over 2, the distance between the two curves will be here. So first, we find the distance function. So the distance will be R1 minus R2, which is 3 minus 2 sine 2 theta, which gives us 2 sine 2 theta. Find the rate at which the distance between the two curves is changing with respect to theta. So the function over d theta equals, we can plug it in or we can take the derivative directly, which gives us 4 cosine 2 theta. We plug theta equals pi over 3 in, give us negative 2. So 1 point for the expression and 1 point for the answer. Let's look at part D. The particle is moving along the curve r equals 3 minus this, so that d theta equals 3. Find the value of dr over dt. Because theta is a function of t, so we have to use the chain rule. Dr over dt equals dr over d theta times d theta over dt. And we plug in, and dr over d theta, which is, we can plug in dr over d theta right here. And we can use our calculator too. And d theta over dt is 3. So dr over d theta, which is negative 4 cosine 2 theta times 3. We plug theta equals pi over 6, give us negative 6. Same thing, 1 point for the expression and 1 point for the answer.